Hello and welcome to this video about Kairos Trusted Boot. This is a short presentation on a high level about the implementation that Kairos made in order to have trusted boot in the operating system. And my name is Mauro Morales. I am part of the Kairos team. And Kairos is a fully open source project, is part of the Cloud Native Computing Foundation as one of the sandbox projects. So that means that you can reach out on the CNCF Slack, on the Kairos channel, on our GitHub repository, or simply leave a message on this video. So let's get started. So first of all, why would we want to move from the cloud to the edge? Well, there are two main reasons. First of all, we already run Linux and Kubernetes on the data centers and we like how this works, so why not also run it at the edge, right? And second is the fact that at the edge we are much closer to the data that is being generated. Plus, we can also give a faster reply to the customer. That, without mentioning the fact that it could be that our edge doesn't have a proper connection to the data center. So another reason why keeping things at the edge might be much better. And just to mention quickly, Kairos has already proven that this is possible by running workloads on dental offices all around the world, to give you an example, or farms even. So it is something that not only can be done, but it's being done and it's working well. Then the thing is, when you're running at the edge, you have many challenges. I'm not going to talk about all of that here because that on its own would require a very long presentation. Within the different challenges that you have, security is a critical one, and even security can have many different issues that you would need to address. I'm not going to do that today. I'm just going to talk about the security issues related to booting mechanisms. This is because at the edge you have this huge problem that you don't have in a data center, which is that your machine is out there in the open, is not protected by your racks with your keys, inside of a room with your keys, inside of a building, again, with trusted security guards, etc., etc. It could be, like I was mentioning, that your edge device is simply in an office or in a grocery store where pretty much anyone could have access and do something dodgy. And particularly I'm talking again about booting, and that means at least two different options. One, someone would change your current operating system by putting some rootkit or any other type of hacking mechanism, so you wouldn't even notice that your system is not the system that you trusted to be there. That is one and a very big problem. And the other problem could be that someone boots a different operating system than the one you intended to have in that machine. That, depending on what they are trying to do, could be a problem or not, right? If they just want to reuse the machine for something else, okay, maybe not such a big deal. If they are using it to extract the data from your machine, well, that obviously would be a lot more problematic. And keep in mind that the focus here is that even if your machine gets stolen, and even if it could be an expensive machine, what we're focusing on is the fact that the intellectual property within that machine could be a lot more valuable than the machine itself. So that's what we're going to focus on. The implementation of trusted boot is not something that Kairos on its own came up with. There are already different implementations out there in the wild, we could say, at least on different operating systems. Windows has its own trusted boot mechanism. macOS has its own trusted boot mechanism with a different name. I don't know it by heart. And one version of trusted boot was pitched already very well by Lennart Pottering. I'm going to let you see this QR code where you can follow, where you can read his Brave New Trusted Boot blog post, where he describes with much better detail than I'm doing here all the problems that you face and the solutions that you want to implement, and also the fact that systemd is producing mechanisms to help us achieve this kind of thing. So again, Kairos doesn't have to come up 100% with a new and novel solution, but we can simply follow, stand on the shoulders of giants, like in this case, Lennart and systemd. So yeah, let's continue. Basically, what Kairos is doing is following a recipe. This is our trusted boot recipe. We're going to do basically 4 items within this recipe. One is what we call unified kernel images, or what is generally known as unified kernel images and unified system images. Second one is secure boot. Third one, TPM-based measurements. And finally, encryption. All of this together makes our little Kairos mascot very happy. So let's dive into it. The first one, like I mentioned, is unified kernel images. What are these? Is basically this one package that contains absolutely everything that you need to boot, and that it will be put in memory. So just to give you a bit of an example, traditionally, this is how Kairos images come, where you have all the different directories, and within them all the different binaries and files that the system is going to need to boot. On a UKI image, this is completely reduced to basically this FE-boot image that contains absolutely everything that you're going to need. And what do I mean with everything? At least in the case of Kairos, it means these artifacts here. It's going to contain the bootloader, it's going to contain the systemd boot configuration, so that you get a menu and select which of the different, for example, active, passive, or recovery images you want to run into. It also contains your public keys, so that measurements can be done. Validation, we're going to talk about that in a minute. And it contains the Kairos FE, which is the system, the full-fledged system, so to speak. Okay, those are the unified kernel images. Now, what we actually use in Kairos is what is considered a unified system image. And the big difference is that traditionally traditionally Linux systems have this process. You go through the bootloader, then the bootloader initiates the init_ramfs, which is basically a very basic version of the system. And this very basic version then does what is commonly known as a pivot and runs the full-fledged system. In the unified system image, what changes is that we don't have this final stage. We finish here. Now, that will require, if you want to dig deep into how this works, you can read a bit in our documentation or make some questions. But just to give you a quick idea, at this point, what we do is we do a fake pivot, where we do a little bit of changes in the system so that the system thinks that it has moved into a full-fledged system. Why is it important to mention this? Well, because if you do a pivot, you would have to do measurements here again. We're going to talk about measurements in a minute, but the whole point of trusted boot is to trust what you are booting. And unfortunately, making measurements at this point of the system and validating them is not as simple. On the other hand, we will have, as I mentioned, here we have a systemd boot, which already gives us all what that we need in order to go against the TPM chip and do the measurements necessary to boot this image. So you're in a much more secure state if you only have this two-step instead of the three-step process, so to speak. Second item in our recipe is secure boot. I'm not going to talk much about this because it's already widely known in Linux, but just know that you will you will tell secure boot that it only should boot your unified system images and using your keys, and that's how it's going to work. That's how you can trust it. Then the third item is, as I was mentioning, TPM-based measurements. I was already talking a little bit about that, but just to give you an analogy of how this works, is like when you're going through immigration process where you have this officer who will ask for your passport and will check the information there, will look at you, and based on that he will make a decision whether you are the person that that document is referring to. Well, we have the exact same, we have a similar process happening with the TPM chip, being the officer, the measurements being the passport that have been generated by a trusted authority, in this case yourself, and the person will be the different artifacts that get measured and validated. What artifacts are validated within a Kairos trusted boot? Well, that's the kernel. That means that if someone tries to put a different kernel on your operating system, it will simply not boot because it will not match the measurements. The init ramfs, so if someone manages to rebuild an init ramfs and tries to run it, it will not run because, again, it will not match the measurements. The command line, which is the one that is used associated to booting the kernel, this doesn't even need to be malicious. Like, any change to the CMD line will be will affect the measurements and therefore it will not boot. But of course, at the end of the day, this is what protects you in the case for Kairos, that nobody is going to change, for example, the immutability of the system. And finally, the etc OS release file, which contains all the details of the specific OS that you are going to boot. So if someone were to install a different system with a different OS release, this will not match and it will not boot. Finally, the last part of the recipe is encryption. Keep in mind that Kairos Kairos Trusted Boot implementation focuses on what we think is most important, which is the user data. So with the help of TPM, this is encrypted, but the rest of the system is not encrypted because at the end of the day, it's just a public Linux operating system. It's just the same files that anyone can download for Ubuntu, OpenSUSE, or any of the different flavors that we offer. And it's worth mentioning here maybe that the system, it sounds a little bit weird, but the system comes just like pretty much like when you download it, and all the configuration happens later on when you're using Cloud Init to do the changes during runtime. So again, just to reinforce on the idea that there is no need to do a full disk encryption, because for the most part, what can be read, the part that is without encryption, there's nothing of value there. It's just a traditional Linux system. And the important thing, the user data, that of course will be encrypted and encrypted against a TPM chip. So all of that together gives us Kairos Trusted Boot, and our little mascot is super happy. But of course, we don't want to leave it just at that. We want to give you also some extra tooling and features. First of all, I want to talk about how we allow you to build unified system images, because this process can be a little bit complex depending how you're doing it. Well, with Kairos, basically you start from a Docker file, which you're probably already very much used to. That becomes a container image with everything needed. as a Kairos operating system. This one can already be used for upgrades or different mechanisms like doing Pixie boot installations, or if you want to have a bootable image, well, the process can also generate for you a bootable image that then can be put through USB, for example, into physical device. The other feature that I want to talk about is upgrades and rollbacks. Basically, Kairos uses what is widely known as A/B upgrades. This is something quite similar to what happens when you're upgrading your mobile devices. So just to give you a quick explanation, a Kairos system will have an active, a passive, and a recovery image always. Whenever you're booting, you're always booting into the active image. Then if you want to make an upgrade, if you want to put this new system, what will happen is that first we take the active image at the moment, we put it into the passive image. That way, if something goes wrong in the process of upgrading, you can just go to your previous image that was already working. And finally, we moved upgraded the new system into the active, so that when you reset the system, you will be running this image basically. If anything goes really, really bad, you can boot into recovery and reinstall the original system that you have, thanks to the recovery mechanism that we provide. And with that, I just want to finish with this conclusion. So basically, Kairos will help you to build these systems that you can trust, that where only the operating system that you trust is going to boot in your device, that allows you to expose the device on any place where people will have access to if needed be. And it's also a very flexible system, so you can extend it and configure it to your liking using Docker files, using Cloud Init. And it's also very easy to do day 2 operations with a Kairos system, because as you saw, you can produce your different unified system images, you can do rollbacks, upgrades, and all of these things. Relatively simple. The menu is so simple when it comes to booting. It's so simple that it's meant to be used by non-tech savvy people at the end of the day. So if you want to learn more about this, here is a QR code to the documentation. This will take you to the architecture of the trusted boot image. If you have any questions, please make them here, or like I said, go to any of our channels, whether it is on the CNCF Slack or on the GitHub Kairos repository. Thank you very much.